Field forces are forces that do not require contact to exert a force on bodies around them. A very common example of such force is the magnetic force that can attract or repel magnetic materials. Another example we learned about in previous lessons is the gravitational force. This force increases with the product of the two masses and reduces with the square of the distance between them. So in this lesson, we will learn more about the force in an electric field. In our previous lesson on force between charges, we learned that the force which attracts or repels two charged particles from one another is called the electrostatic force, or Coulomb force, named after the French physicist who first defined it. Electrostatic force is an inverse square law, just like gravitational force. The magnitude of the force is inversely proportional to the square of the distance r between the two charges. The magnitude of this force is directly proportional to the product of the magnitude of the two charges Q1 and Q2. As usual, we need a proportionality constant K to equate the variables. K is called the electrostatic constant and is equal to the inverse of 4 pi epsilon naught, where epsilon naught is called the permittivity of free space, having this value. This gives us a value of K to be approximately 9 times 10 raised to power 9 Newton meter squared per Coulomb squared. So, the electric field force felt by a charged body is given by F is equal to K multiplied by Q1, Q2 divided by R squared. This force acts along the line connecting the center of the charges. If they are like charges, then the force is that of repulsion. But if they are unlike charges, then the force is that of attraction. The force one charge exerts on the other is equal but opposite to the force the second exerts on the first. And this is according to Newton's third law of motion that states that action and reaction are equal but opposite. And this is Coulomb's law in a nutshell. It states that the magnitude of the electrostatic force between 2 point charges is directly proportional to the product of the magnitudes of these charges and inversely proportional to the square of the distance between them. Check out our solved problem for further insight. See you there.